that last example of applying a logarithm, setting a limit equal to some letter L and then taking the natural log of both sides to simplify an exponent reminds me of a trick called logarithmic differentiation. It enables us to deal with, again, taking derivatives of things with strange exponents. For example, if y is x to the xth power, what is the derivative dy dx? See, if it was just x to the something, x to a constant, x to the 10th, it's 10x to the 9th. And if it was 10 to the x power, it would be 10 to the x times the logarithm of x, if I'm not mistaken. A logarithm of 10, if I'm not mistaken. But if you have variables in both places, what do we do? What do? We take the natural log of both sides. We say the natural log of y is the natural log of x to the x, and that enables us to pull that exponent down. Logarithms are what you do when exponents are bugging you. You bring this x out front, x times the natural log of x. Now we can use implicit differentiation. I probably should have talked about this when we were doing implicit differentiation in Calc 1, but, well, Calc 1 was hard enough. You take the derivative with respect to x of both sides. What's the derivative of the natural log of something? It's 1 over the something times the derivative of the something. We don't know what the derivative of y is. We call it dy dx. If we knew what the derivative of y was, we would have been done at the beginning. Right, we're going to solve that in the end, and that will be what we want. Over here, we have to use the product rule. We take the derivative of x and we get 1, and then we leave the natural log of x alone, and then we add the x left alone times the derivative of the natural log of x, which is 1 over x. So, let's say 1 over y times dy dx is natural log of x plus 1. Now you multiply both sides by y, and you get dy dx is natural log of x plus 1 times y. What is y? Y was x to the xth power. So, the derivative with respect to y of dy dx, the derivative with respect to x of y is natural log of x plus 1 times x to the xth power. And we wanted to know what is dy dx? The answer is this. To put it all in one line, the derivative of x to the xth power is the natural log of x plus 1 times x to the xth power. Not something I have memorized. I'm sure some people do, but what is better is to know that when you have something with exponents and you're trying to take the derivative of it, and this works if you want to solve y equals, say, 5 to the x power. Again, take the natural log of both sides, use implicit differentiation, you will get the answer. This general trick is called logarithmic differentiation.